Hello everyone. Now I am going to explain you about how to find out the currents of a mutually coupled coils. So here the two coils are there. One coil is which is connected in series with this capacitive value. Again that is connected in series with the source voltage. And the second coil which is connected in parallel with the 12 ohms resistor. And we know if the two coils are there, there will be an mutually induced voltage and that value is J3 ohms. And here we have to observe one thing. Here all the values are in equivalent impedance values. Now we are able to apply the KVL or KCL to this one. So here I am applying a KVL to find out that currents I1 and I2. So before finding that I1 and I2, here I want to tell one important point. So whenever the two coils are there, so there will be a mutually induced voltage. So whenever you are considering the voltage drops of this coil, so you have to consider the self voltage as well as the mutual voltage. Okay. Similarly, here we have to consider the sign of that mutual value, either it may be positive or negative depending upon the currents entering into this dot. See here, so in this one, here the I1 current is entering into this dot and here the I2 current is exit into this dot. So whenever the current is both the currents are enter into the dots, we have to take down the mutual sign value as positive, nothing but same as the coil one. Similarly, when the current is enters and exit, means enter and exit means mutual sign value as simply negative. Okay, now we are going to apply the KVL to the loop one. So this is the first loop. So I am applying the KVL to this first loop. So here this voltage, this is in polar form. If you convert into a rectangular form, this will be the 12 volts. Just apply KVL to the loop 1. So here the 12 volts is nothing but the drop across this capacitive value, that is simply I1 into minus J4 ohms. Okay. Then again here the current is entering into this dot. Again this is the drop across this coil is nothing but I1 into J5 ohms, as well as whenever we consider the current across the voltage across these coil, we have to take down the self value as well as mutual value. So this mutual value is, we know mutual is always because of the second current, so that is simply I2 into J3. But here we have to concentrate on the sign of this mutual value, because here the current is entering into this first dot, as well as whenever you consider the second current, so the second current is will go to the coil, again will exit from the dot. So here the current is entering into dot, here the current is exit into dot, means here the mutual value is simply negative sign. So this is a negative sign. So by here, so this is the KVL equation I got for the loop 1. So here this is a 12. I am writing the common terms at one place. So here the I1 is a common term. So we are getting I1 is J5 minus J4 and I2 is minus J3. So we are getting them, by simplifying it, we will getting the equation 12 is equal to I1 into J1 plus I2 into J3. Make it as equation 1. Similarly, apply to find out the second one. I am applying the KVL to the loop 2. So here whenever you are applying loop 2, you will get the 3 voltage. So one is self voltage, one is mutual voltage, another one is voltage across this 12 ohms resistor. So here for the second loop, so we are applying, there is no voltage source, so the total voltage is 0. Again here the self value I2 into J6, again mutual value is minus I1 into J3, because here, so this is the self value I2 into J6 and mutual value is I1 into J3. Again here this is the drop across, it is I2 into 12 ohms. So this is I2 into J6 minus I1 into J3 plus I2 into 12. Just to simplify it, so here 0 is equal to I1 of minus J3 and I2 of 12 plus J6. So now with these equations 1 and 2, and write it in matrix form like Ax is equal to B. So here I am writing, so this is the first term J1 and this is the second term minus J3. So J1 minus J3 and the second term is minus J3, and here this term is 12 plus J6, which are the currents of I1 and I2 with the voltage of 12 and 0. Okay, here to find out the currents I1 and I2, first of all we have to take down the debt value. So here the debt value is nothing but simply this value J1 minus J3 of minus J3 into 12 plus J6. So by simplifying it, you will get a value of 3 plus 12j. Here 3 plus 12j is in rectangular form. Now you have to convert this value into polar form. Okay. So you will get by converting it to a polar form, you will get a value of 12.36 at an angle of 7.96 degrees. Okay. Similarly, find out the del 1 current. Del 1 current is nothing but simply replace the first elements with your voltage. So here the voltages are 12 and 0, and then make the second column as it is, minus J3 12 plus J6. So by simplifying it, I am getting the del 1 value as 144 plus 72J. So by changing it to a polar form, you will get this value as 169.99 at an angle of 26.56. Similarly, find out the del 2 value. So del 2 is nothing but simply replace this second column with the 12 and 0. So here the make this column as it is, and I am replacing the second del means make this second column as replace with the voltage 12 and 0. So by simplifying it, so here this 0 into j1 is 0, again minus of 12 into minus j3, here minus into minus you will get plus. So you'll get a 36J. We know 36J is nothing but a 36 at an angle 90. So here to find out the current I1, we have to take down the value of del 1 as well as del 1 by del. So we know the del 1 value is 160.99 into 2656, as well as del value is 12.36 at an angle of 75.96 degrees. Okay, by simplifying it, we'll get an angle. We get the value of 13.02. So this is the, if you divided, you will get the value of 13.02. Again here the angle will be subtracted here. So this is 26.56 minus 75.96. You will get an angle of 49.4 degrees. So this is the I1 current. So 13.02 amperes. Similarly, if you find out the I2 current, so I2 is also simply delta 2 by delta. So here the delta 2 value is 36 at an angle of 90, and delta is 12.36 at an angle of 75.96 degrees. By simplifying it, we'll get an angle of 2, we'll get a current of 2.91 at an angle of 14.04 amperes. So here they are also asking find out the voltage across the 12 ohms resistor. So across the voltage across the 12 ohms resistor simply is that second current I2 into 12 ohms. So here it is, V12 is equal to second current is 2.91 at an angle of 14.04. Just multiply with the 12 ohms resistor and we'll get a value of 34.92 at an angle of 14.04 volts. Thank you.